So what is intensity? Now the actual formula for intensity is energy per unit time per unit area lah. Which some people will combine these two together, energy per unit time, to get power per unit area lah. So the unit will be watt per meter squared. So this is the first formula. Okay, this is the first formula for intensity. So the second formula for intensity is the relationship between intensity and amplitude of the wave lah. So here they said that intensity is proportional to amplitude squared.
Yeah.
So what it means is when you double the amplitude of the wave, the energy contained is 4 times greater, which explains let's say you are on the boat, and let's say a wave of 1 meter hits your ship, then your ship starts to turn to the side, right? Because you feel the impact. But if let's say the wave of 2 meters hits your ship, you will feel 4 times the energy, not just double the energy. So the way to solve using this relationship, because it's just proportional, so you need equal, right? You can either put as I equals to Ka squared, where you need to find the constant, or you can actually use ratio. I2 over I1 is equals to A2 squared over A1 squared, because your K is constant. So either one of these. Now the third relationship that you learn is intensity is proportional to frequency squared. Now if they want you to use this relationship, they will tell you, because this relationship is like addition one. Some questions must use, some questions no need to use one. So if they specifically mention, then you use. Okay, so when you say intensity is proportional to frequency square, that means the higher the frequency of the wave, the more energy it has. For example, if you look at the electromagnetic spectrum, you start with the lowest frequency, for example, radio wave. As you go up to X-ray or gamma wave, the highest frequency, then it contains more energy as well. Something like that.
Yeah.
So then you will get intensity equals to Kf squared, or intensity I2 over I1 equals to F2 squared over F1 squared. So second relationship. Second relationship, but this is the actual formula. So this is formula, these are two relationships. The third relationship is between intensity and the distance from the source. Now they are assuming it is a point source. Now what is a point source? That means you imagine that you have this dot here that emits the wave in all directions, including the z direction, which you can't see the depth one. So what will happen is the wave will expand like a ball. So when it expands like a ball, the intensity, remember, is energy per unit time per unit area, or power per unit area. So you take the power, you divide by the area of a sphere, which is 4 pi r squared. So you take power over 4 pi r squared, then you will notice that your intensity is inversely proportional to r squared. And r being the distance from the point source to that point where you want. Okay, so this one is compulsory for you to know. That means this is compulsory. This one no need to memorize. If you are supposed to use, they will tell you.
Okay.
So finally, you will get intensity equals to K over R squared, or I2 over I1 equals to R1 squared over R2 squared. So this is inverse relationship. So it's 2 over 1 equals to 1 over 2. Alright, so you can use either of these to solve lah.